Every single time you fire up your computer, you're actually plugging into the end result of a 50-year corporate war. It's this wild story of alliances, betrayal, and a pretty daring heist that literally defined the architecture of our digital world. So let's dive into how this epic rivalry built the very machine you're probably using right now.
So if you could shrink down and look inside your machine, you'd see this incredible city of silicon, just a super dense network of pathways carrying information. And for decades, the design of this whole city was dominated by one empire and its scrappy, persistent rival.
But to really get why these two companies fought so hard, we kind of have to back up and ask a really basic question. How does a human idea, something written in code, become an actual action inside these crazy complex circuits? Well, the answer is a journey of translation. Okay, so to understand the battlefield, right, we first need to get a handle on the language of the combatants. It's a journey that takes our human thoughts and translates them step by step into the machine's actions.
The easiest way to think about this is like a super sophisticated translation service, or maybe an assembly line in a factory. A programmer writes a source program in a language a human can read, like C. The preprocessor then kind of cleans it up. The compiler translates that into a much lower-level language called assembly. The assembler then turns that into raw binary, the ones and zeros the machine can understand. And finally, the linker bundles it all together into a program you can actually click on and run. Each step takes our logic further from words and gets it closer to pure electricity.
All right, and this slide, this really gets to the heart of that whole translation process. We start with C code, something a person can actually write and understand. That gets turned into assembly, which is this sort of cryptic shorthand that acts as a bridge between our language and the hardware's. And finally, it all becomes machine code, just numbers. This is the only thing the processor, the CPU, actually understands. There's no logic we can see, just the raw binary language that it executes.
And that brings us to the company that basically wrote the rulebook for that machine language and built a massive empire in the process, Intel. So back in 1978, Intel drops this processor called the 8086, and with it came an instruction set, a machine language called x86. By becoming the brain of the original IBM PC, x86 pretty much became the industry standard. Its killer feature was strict backwards compatibility, meaning a program from 1985 could, in theory, still run on a computer today. This whole ecosystem was built on a philosophy called CSIC, or Complex Instruction Set Computer. The idea was simple: make the hardware really, really smart so it could understand complex, multi-step commands all in one go.
But when you build an empire that powerful, it starts to make people nervous. And that nervousness, well, that's what gave birth to Intel's greatest rival.
Okay, so picture this. IBM is building its world-changing personal computer, but they've got a big problem. They just couldn't risk betting their entire business on one single company, Intel, being able to make enough chips. They needed a backup plan.
So to get this monster contract, the most important contract in tech history, IBM basically forces Intel's hand. Intel had to license its crown jewels, the x86 blueprints, to a much smaller chip maker called Advanced Micro Devices, or AMD, so they could act as a second source manufacturer.
And then, the PC just explodes. It's a phenomenon. Intel sees these unimaginable profits they're having to share. So with their next big chip, the 386, they broke the agreement. They cut AMD off completely, trying to create a total monopoly and leave their old partner in the dust.
Now this should have been game over for AMD, but instead it triggered one of the most brilliant and ingenious feats of reverse engineering in corporate history.
I mean, the stakes could not have been higher. AMD is literally on the verge of going bankrupt. They had to create a chip that was 100% compatible with Intel's 386. It had to speak that exact same x86 language, but they couldn't use a single shred of Intel's copyrighted code to do it.
And how they did it is just brilliant. They set up what's called a clean room design. One team of engineers, let's call them Team A, took apart the physical Intel chip. They were legally forbidden from writing a single line of code. Their only job was to create a super detailed technical manual that described exactly what the chip did for every possible command. That manual was then handed over to a completely separate group, Team B, who had never even seen an Intel chip. Their job was to build a brand new chip from scratch that just followed the instructions in the manual. Of course, Intel sued. Big time. But after this long, brutal 8-year legal battle, the courts actually sided with AMD. They ruled that AMD's method was totally legal. They hadn't stolen Intel's design, they had simply created their own design that produced the exact same results. And that decision basically guaranteed we'd have competition in the PC market for decades.
And that legal victory? It basically kicked off an arms race, a cycle of innovation where, for decades, one company would get ahead only for the other to come roaring back. And that's what's driven the incredible performance gains we see today.
And you can see from this timeline just how relentless that pace of change has been. We went from the 16-bit chips in 1978 to the 32-bit revolution with the 386, which is what enabled modern operating systems. Then we had the massive performance jump of the Pentium, the shift to 64-bit to break through memory barriers, and the move to multi-core processors for better efficiency. And now, we're in this new era defined by AI and something called chiplets, where smaller, specialized chips are combined to make a more powerful whole.
But in the last few years, the whole dynamic has just shifted dramatically. Intel, who was the undisputed manufacturing king for so long, hit major delays trying to build smaller, more efficient chips. Meanwhile, AMD made this brilliant pivot. They stopped trying to build their own chips and instead used a third-party manufacturer, TSMC, who had mastered the process. And with their Zen architecture, AMD went from being the budget option to the performance leader. Just a stunning reversal of fortunes.
And here is the absolute best part, the ultimate irony. When the entire industry needed to move from 32-bit to 64-bit processing, it was AMD's design that became the standard. After trying and failing with their own approach, the giant, Intel, was forced to license the 64-bit architecture from its tiny rival, a design they still use in every single chip they make today.
But here's the twist. While these two giants were locked in their 50-year war, a totally different way of thinking about chip design was quietly getting stronger, and it's now threatening to upend their entire empire.
Remember we mentioned CISC earlier? That's the Intel and AMD way. Make the hardware super complex so it can handle powerful multi-step instructions. But there's another way, RISC, or Reduced Instruction Set Computer. Here the hardware is much simpler, designed to do only very basic things but do them extremely fast. This is the philosophy of ARM, the company whose designs power pretty much every smartphone and Apple's new M-series chips. Because the hardware is simpler, it's incredibly power efficient, which is exactly why your phone can last all day, while a beastly gaming laptop might die in just a few hours.
For years, everybody thought RISC was just for, low-power stuff. But with chips like Apple's M-series delivering just insane performance and efficiency, that's just not true anymore. The entire x86 empire, built by Intel and AMD, is now facing a genuine, existential threat from this fundamentally different approach. So, when you boil it all down, it's this. That fierce 50-year dogfight between Intel and AMD gave us the incredibly powerful computers we have today. But as our focus shifts to mobile computing, AI, and all-day battery life, the question is no longer just Intel or AMD. It's whether their entire x86 philosophy, born from a corporate war in the 1980s, can even survive the challenge from this newer, leaner, more efficient rival.